Hey everybody, I wanted to just highlight today a type of basically remote IO that I recently got to kind of work with a little bit. I thought they were pretty impressive. So what this is these are Moxa, they're universal controllers and IO. So they have quite a bit of different products. If you just go to their website and look at like controllers and IOs, they have all sorts of different stuff. They've got full DAC systems, all sorts of stuff. This is specifically the one I was messing around with, was this IO Logic E1242, which is basically just has mixed IO. So we've got 4 analog inputs, 4 digital inputs, and 4 digital inputs or outputs. So yeah, a good mix of kind of stuff. You can kind of go through on the Moxa website. You get more details about the different information. Right, we can do pulses, right? I can generate pulses on those digital outputs. It can count number of pulses, etc. And yeah, kind of cool. It can measure, 0 to 10, 0 to 20 milliamps, 4 to 20 milliamps, etc. So I can configure the analog inputs for different types of measurements, and I don't have to add like an external shunt or anything like that. Sampling rate, not super fast, but if you just need like kind of remote monitoring of some stuff, really, this is all you need. Now, what I think is really cool about these is they support a whole bunch of different protocols. So, for example, there's a web interface you can use to interact with this. They have, basically some desktop software you can install. But if you're trying to integrate this with LabVIEW, for example, it supports Modbus TCP, so I can talk to this over Modbus TCP. There's Moxa AOPC, which is just OPC, right? So you can connect to it with OPC. There's this MXIO library if you want like a custom driver set. It also works as an Ethernet IP adapter, so I can then talk to it over Ethernet IP. And I also wanted to highlight it supports REST APIs. So there's a whole bunch of different ways I can talk to this. I can program this, remote IO in basically any programming language out there, because pretty much everything can do REST APIs. Pretty much anything can do Modbus. Ethernet IP is a little less common, but it's another option, right? So yeah, really cool. So that's kind of the DAC kind of rundown. And like I said, this is the specific one that I've worked with. I wanted to show you kind of just some of the ways we can program this. So like I said, we can just straight up use Modbus. So and there's nothing crazy here. Basically just passing in the address to it, and we are reading or writing registers. So really pretty simple. We're just establishing a connection, reading this input register, and closing the connection. So really not a whole lot. All of these are pretty much the same for Modbus. We're just reading and writing, registers and whatnot, which if you ever worked with Modbus is very straightforward. I did want to highlight some of this REST stuff. So you can do a lot of these same things using REST, which I thought was really cool because you can actually retrieve a lot of information this way. So I wanted to show this. For example, if we read analog, we get a whole bunch of information. So you can see here, I get all the details about the analog channels, the raw value, the scaled value, right? So, that channel's reading 0.002747, the min and the max it can read, scaled min and max, etc. I get all this information for all the different analog input channels. It's just JSON. I can parse it, work with it that way. Same thing for like digital inputs, right? I can basically query the digital inputs and I get basically, hey, these digital inputs, this is the mode it's in and this is the status, whether it's low or high, for all of my different digital inputs. So I get all of those things in one simple HTTP request. And even, device information, right? So I can query it and I just get JSON that says, hey, this is a E1242. Device name doesn't have one assigned to it. Uptime, I can see how long this has been running for. You can see it's been running for a very long time without being rebooted, and the firmware version. So kind of get that, which is pretty cool. I can show you what some of these REST functions look like. It's actually really simple. So yeah, we're just can open up context help, just opening the handle. We're adding this accept header for vdn.dac.v1 and setting the content type to application JSON. This is not required. I'm just listing my headers to make sure I've been setting them correctly. And then we're just doing an HTTP GET to HTTP, the IP address, API/slot/0/IO, and then AI for reading analog inputs. And each one basically has its own endpoint, but it's all basically this exact same format. Really simple to just read and write data. So using standard communication protocols, so basically any language can do it without a custom driver set, which I think is really cool. Can show you as well on that digital inputs what that looks like. We're basically doing everything's the exact same, just instead we're connecting to that /di endpoint. So super simple to get working. I've actually been very impressed with them, and they have a whole bunch of other devices as well for if you wanted EtherCAT, different communication protocols. They've got all sorts of different stuff as well. So if you're interested in some low-cost IO, I think this unit cost me like $180, so it was pretty cheap. But you get a mix of IO and remote capabilities, so I think it's worth it 100%. Trying to get a similar, NI device that's network connected with a mix of IO, it's going to be a little tricky. So, for just cheap IO, I think it's great. Really cool devices. They've got a whole mix of different stuff depending on what your needs. If you're interested looking at different DAC options, definitely give Moxa a look. And thank you guys for tuning in.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.